Hello everyone, today we're going to talk about the actinides and lanthanides on the periodic table. So here we have the periodic table. Here's a brief review. The periodic table organizes the 118 known elements by arranging them based on their atomic number, which is the number of protons in each of their atoms. The elements are placed in rows called periods and columns called groups. Elements with similar properties sit in a group. This table is periodic because the characteristics of the elements follow a pattern. New elements may be added to it in the future. So these two rows, known as the lanthanides and actinides, are not periods. They sit next to group 2, but they make the table very wide, so they are moved to the bottom. So here are the lanthanides and actinides. Here's lanthanum and actinum, which is why they're named lanthanides and actinides, and are the ones in front of the whole region right here. So here we have the key: hydrogen, alkali metals, alkali earth metals, transition metals, lanthanides, actinides, the boron group, the carbon group, the nitrogen group, the oxygen group, the halogen group, and the noble gases. So here we have copper. The atomic number is unique to each element. Each element has a unique symbol made of letters, and there are two types of classifications for the elements: the periods and the groups. Periods are a row of elements with the same total number of electron shells in their atoms, and groups are a column of elements with the same number of electrons in the outermost shell of each of their atoms. So let's continue. Here we have the lanthanides and actinides. Actinides are the group of elements with the atomic numbers 89 through 103 in the periodic table. They have similar properties to lanthanides, but they are more reactive. Actinide atoms are very large and are radioactive. Most of the elements in this group are artificial. Key facts: many actinides are artificial. Actinides are more reactive than lanthanides and easily react with air. Actinides have large atoms. Actinide atoms are radioactive. So the physical properties of actinides. Pure samples of actinides are very rare because they are radioactive. Actinides are usually found in trace amounts inside certain minerals. So here we have autunite. It's a mineral containing traces of actinum. Actinum is element number 89. Here we have monzonite. It's a mineral containing thorium. Thorium is element number 90. Here we have Californium. Californium and artificial actinide are contained in pellets in the laboratory. So here we have Californium. We don't have an image of it. We have the seal of California. So here we have uranium. Pure uranium is shiny and gray. Uranium is element number 92. Californium 98. Here we have torbernite. It's a mineral containing traces of proactinium, and proactinium is element number 91. So we're going to talk about the next group, the lanthanides. Lanthanides are a group of elements with the atomic numbers 51 through 71 in the periodic table. They have similar properties to transition metals. Lanthanides are a group of elements with the atomic numbers 51 through 71 in the periodic table. They have similar properties to transition metals. Lanthanides tarnish, lose their shine easily in air, and they are sometimes stored in argon or under oil to prevent this. Physical properties of lanthanides. First, key facts: lanthanides are the elements with the atomic numbers 57 through 71 on the periodic table. They are commonly found in Earth's crust in compounds with other elements. Lanthanides are reactive and form ionic compounds with nonmetals. Lanthanides have large atoms. So the physical properties of lanthanides. Lanthanides are found mixed with other elements in the Earth's crust and must be extracted and purified into pure samples. So here we have lanthanum. Lanthanum is element number 57, and here we have neodymium. Neodymium is element number 60. Here we have gadolinium. Pure gadolinium is hard, so gadolinium is element number 64. And here we have cerium. Cerium is element number 58. And here we have samarium. Samarium is element number 62. And here we have europium. Europium is element number 63. Pure europium has golden crystals. Here we have terbium. Pure terbium is so soft it can be cut with a knife. Terbium is element number 65. And here we have thulium. Thulium is element number 69. So the common uses of these lanthanides. So what are the lanthanides used for? Lanthanides are used to manufacture certain objects because they have useful properties. For example, lanthanum used in bulbs reduces the amount of yellow light emitted, and some TV screens have small amounts of cerium, which emits color. So again, cerium is element number 58. So TVs use element number 58 in small amounts because it emits color, which is useful for the TV. Here we have fluorescent bulbs, TVs, and guitars. This metal is made of samarium cobalt alloys. So samarium is element number 62, and cobalt is element number 27, as seen here. So the metal is made out of alloy, which is a combination of both the element number 62 and element number 27. So those were the lanthanides and actinides explained. That was the introduction because there's still more detail to talk about the elements. I'll talk more in depth on those elements in a separate video. Other than that, if you guys like this video, make sure to like, comment, subscribe. Thank you guys for watching. Have a great one.